energy. He has over 20-year experience in the sector. Christian's worked in several sectors: energy efficiency, geothermal. He's an expert in funding and climate funds, hydrogen. So he has a vast experience and worked in different sectors. So he will provide a very comprehensive view. He has 2 master's degrees in engineering, one of the University of Chile, engineering biotechnology, and the second from the Royal Institute of Technology in Switzerland. He'll be our first panelist, and he will provide a more comprehensive view. After that, Patricia Colaferro will join us online. She's the head of sustainability of Ala Acero. She's an environmental engineer, postgraduate degree in ESG and corporate sustainability, and over 15 years of experience in sustainability in the steel sector, and he has vast experience in multinationals and different organizations, project development, environmental projects, especially those that are highly complex, that require community engagement, state engagement, and she has a lot of experience in energy transition, institutional relations, and healthcare and security in the steel sector. After that, Rodrigo Sepúlveda will focus on a specific case. He's a civil engineer in electricity and a master's in energetic economy. He has over 15 years of experience in the steel sector, and he is currently the Chief of Energy Development at Aceros ASA in Chile, and he is a VP of the electric client non-regulated client association known as ASENOR. He leads the company's roadmap towards carbon neutrality, focusing on renewables, electromobility, and strategic management of contracts, whether power or gas. This is a leading company in the industry, and they have a very low carbon footprint. And to close our panel, we are leaving for now the steel sector, and we are going into the cement sector. Ricardo Pareja is the Director of Innovation and Climate Action at FICEN. And well, he'll tell us about FICEM. He is an acoustic engineer, a master's degree in environment from the University of Santiago in Chile, and postgraduate studies in mining security in the service of mines and geology. So we have 3 strong Chilean representatives in person, and Brazil is joining us online. Ricardo and I have over 25 years experience in management, sustainability, and climate action in the cement and concrete industry. So together, the 5 of us have over 100 years of experience in the industry. From 2016 to date, he's been the Innovation and Climate Action Director at FICEM. He's led several projects like this cement and concrete roadmap towards carbon neutrality. He's led different regional and international initiatives showing the commitment the industry has to reduce emissions. So without further ado, since our panel's been introduced, let me start with Christian. Christian, I have 2 questions for you, a more general and a more specific question. The first one, what are all the actions being undertaken? And Christian, for you in particular, what's the role that the IDB plays in the decarbonization process being undertaken by the heavyweight industry? So, Christian, could you provide the IDB perspective? Thank you, Gaston. Thank you, Olave, for the invitation. It has been a great week, and we are coming to an end with the heavyweights, right? So let's go straight to the point. There are a few of us here today, so please feel free to ask questions at any time. So what are we doing at the IDB in terms of the heavyweights? Well, as Gaston mentioned earlier, the heavyweight industries has a significant participation in terms of international emissions, global emissions, and our colleagues will also speak about this and about emissions in Latin America and the Caribbean, but they're quite significant. We know that to reduce, it is not enough with energy efficiency or electrification of processes. We need to go for example, greener fuels like hydrogen. And we need to think about carbon sequestration or biocarbon sequestration. That's where we need to aim. We have cement, we have steel here, we have aluminum, pulp, paper. And fertilizers is something we need to take into account. Fertilizers is another industry that we should pay attention to. They are closely linked to agriculture. And if we're thinking about producing green urea, well, it has to come from green ammonium, from green hydrogen, and that will have an generalized impact. So what's the IDB doing? We started working with FISEM, with Patricia, who's joining us online. We can see her on screen. In terms of industrial decarbonization, we started analyzing what are the potential decarbonization roadmaps in the steel sector and cement sector. Then we started working with pulp and paper and aluminum. So we wanted to show decarbonization routes that have been validated by the sector. We don't just want to work on decarbonization routes that make no sense or have no buy-in, and then allocate costs, locations, countries where it really makes sense to implement them. We realized that it made sense to have clusters where the steel industry could work with the cement industry, as they have many synergies and waste from one industry can be used as input for the other. And my colleagues will be better able to explain this. And to date, the heavyweight industry, well, together with the oil industry, have been the bad guys in this movie, right? We are now realizing that there's no replacement for cement, first of all, for steel. We need to live with those products. We need to coexist with those products. And what's left? Decarbonization. The same with aluminum and the rest. So we need to find decarbonization roads. We are now working with climate funds to look at funding possibilities for the technology changes in these industries. So that is sort of the road that we are taking. That's interesting, Christian, because it shows, and that's something that we have heard repeatedly over the course of this week, how we can start building connections. 5-6 years ago, we started speaking about electricity generation, transition, and now, as he just said, having mining panels is very normal. Because we all know that if we don't look at critical minerals, we will not speak about energy transition. Without electrification, we can't speak about energy transition. Without cement, steel, decarbonization of those sectors, we will not have energy transition. So now we are adopting a more comprehensive perspective or mindset. So let's go to the steel sector, to Patricia. And Patricia, what are the big milestones that have been achieved for emission reduction? We need to look at not just where we want to get, but what's been done. And what are the next challenges for the steel making industry? Patricia, the floor is yours. Hi everyone, good morning. First of all, I want to thank Olame, I want to thank Gaston for the invitation. It is my pleasure to share the panel with my colleagues from the IDV, Acero Sasa, FISER. Thank you. I'm very sorry I couldn't be there in person, but I had, well, a lot of the events coincided with the Alacero Congress. So after this panel, I'm running to a second panel. But next year, Gaston will make it work so we can be both in person in both events. Before starting, let me just do a quick introduction about Alacero. We are the Latin American Association of the Steel Industry. We have a history of 60 years. We started in Santiago. Today we are located in Sao Paulo. We have over 60 member companies in three main types of stakeholders: national chambers, supply chain industries, and finally the steelmaking industry itself. We have 95% of the steel production in the region. We cover 95% of the steel production in the region. Now, Gaston, to answer your question, I will mention 5 points. I will explain the role of Alacero in society and for the decarbonization and energy transition. Then I will provide some figures that are part of our emissions process in the sector. Then the main ways of producing steel, what are the options for decarbonization, and finally what we believe are the opportunities for the region. So the first item, what's very important when speaking about steel as a material, is that it has different properties that allow it to be 100% recycled. So in that sense, we are contributing to circular economy and decarbonization. We also play a very significant role for the development of society as we are present in different sectors. We are part of the infrastructure, healthcare, housing, mobility. So human development is fully dependent on steel. Cement and steel are always present, so we need to find a solution to decarbonize it rather than eliminating this product or material, which is not possible. It is really a main actor also in the process for decarbonization, as it is present in wind towers, in solar panels, in the energy distribution and the distribution of other fuels. So that is our role, and that's why steel is so important to the world. Now, looking at figures, as Gaston just mentioned, the heavyweight industry accounts for 29% of GHG emissions globally. As part of these 29%, steel accounts for 8%. We are responsible for 88% of global emissions. We are working on this. We know how important it is to decarbonize our process. Now, if we look at the region, the sector contribution is 2.4%. As Christian mentioned, the main responsibility for emissions is associated to agriculture and the use of soil and fertilizers that is responsible for 50%. Now, it should be noted that we have two types of emissions: direct emissions, which are reach level one, that are directly related to the productive sector in the industry, and the indirect, which is scope 2 or level 2, associated to acquired or purchased power by the industry, and scope or level 3 associated to the supply chain, stream, downstream, in the productive process. So in that sense, we can find the steel industry that 78% of our emissions are associated to level 1. We use an indicator to measure the emission rates, and we call them intensity, CO2 intensity. And that means the amount of tons of CO2 emitted per ton of steel produced. So we can look and compare the figures and look at the 2022 figures. If we look at those global indicators, we're going to see that intensity is 1.91. If we look at China's figures, in addition to this global number, their indicator is 2.24 tons of CO2 per steel ton. And now in Latin America, we have an indicator of 1.55 tons of CO2 per steel ton. So that's important to stress, as our sector's contribution might not be as significant as others. We have a quite favorable indicator in Latin America, but still, of course, we're still working in order to reduce our emissions. Now, that's the third part of my answer. So which are the main ways of producing steel? And we can see that slide here as a more visual support, a visual aid, because how we produce steel will change from energy input and emission perspective. If we look at the slide, we can see that the first one, the first author, or the integrated route set uses coal as the main input, and therefore the footprint's higher. Now, 2.3 CO2s per ton of steel produced if we choose a route. This is an important route in Latin America because our production is 51% based on that route, and it is important, but will create and produce the waste that will be used, and we can also produce special types of steels. In the middle, we have the direct reduction route, and the source of energy in this case is natural gas, and a footprint of 1.7. And finally, we have the power route, where we have 100% power or electricity as a baseline, and a lower footprint of 0.7 of tons of CO2 per ton of crude steel. They are all very important. They are all part of what we can find in Latin America, and we see different visions and different objectives for decarbonization. In the decarbonization process, it's always important to consider the heterogeneity, not of the different routes alone, but also where are the plants located, what are the geopolitical conditions of that location, the availability of natural resources, types of energy, and how old the plants are. This is very important for the decarbonization route. Let's go to the next slide. And let's look at the roadmap that we have for the sector in Latin America. In general terms, we are going to divide these actions in the medium term, and this is already in place in our region for the sector, and we also have long-term actions. Those mid-term actions are in line with the Paris Agreement objectives. We are working in energy efficiency programs, renewable energy penetration, the increase in the use of waste, natural gas as a transition fuel, biogas as well. We are always looking into the possibility of applying biomass. That's one characteristic and opportunity that we have in the region. So those are some of the aspects considered in the sector. When looking at 2050, the longer term, we speak about disruptive technologies. So green hydrogen, the implementation of sequestration, use and storage, carbon sequestration, use and storage, and always considering significant alliances between sectors, governments, financial institutions to be able to go further. And finally, we have great opportunities in Latin America. For example, the opportunities in the region in terms of natural resources, geographic conditions. Today, we have over 15 projects published on the production of renewables generated by the steel sector in Latin America. These are projects in countries like Chile, Argentina, Brazil, Colombia, Dominican Republic, Ecuador, Peru, and so on. There are many that have an investment of around $1.6 billion. So that is the general view of what we see in the steel sector for Latin America. Great, Patricia. From your presentation, I could say that, well, first of all, communication is so important. And why am I focusing on this? Well, because sometimes industries like the steel industry, as Christian mentioned in his introduction, sometimes we also have difficulties when it comes to public opinion. All of these actions where we are taking on a leading role, it is very important that we raise awareness not only within the industry itself, but also with authorities and the general public. Events like this play that role. We want to disseminate good practices so we can have a multiplying effect for other sectors to appreciate the importance of different actions and then how we will capitalize it. This is not just something that we do for climate action, but we can also appreciate all the benefits that will fall in the industry, not just about sustainability, but productive investment as well. So thank you for that description of the general situation in the steelmaking industry. Rodrigo Sepúlveda from ASA. ASA's been promoting the circular economy for many decades. It's part of your DNA. So how could we replicate this more sustainable model? But at the same time, what have you done already? What has ASA done already to contribute to the decarbonization in the steel industry? Thank you, Gaston, for your question and invitation. Thank you to Olave, Christian, Patricia, Ricardo, and everyone here today. As an industry, steel industry, we cannot stay outside the transition. So we are happy that you've invited us here today. We participated in the panel with public authorities, with the different ministries. I do have a presentation, if we can please put it up on screen. We have experience of 70 years producing steel. We are working in the electric or semi-integrated steel makers, and we are based in Chile. Our purpose is green steel to build a more sustainable country. And we are the main producer of green steel and the largest scrap recycler. We recycle around 500 to 600,000 tons, like 4 football stadiums with 60,000 seats a year. So really, we recover scraps. with stocking centers, with recyclers to be able to reach that figure. Why is circularity important? Well, first of all, because we can recycle, we can reuse. On screen, we can see some particular examples for our industry. We recycle waste and scrap from mining or household waste, black scrap from our processes. We also focus on reducing the use of energy and input within our processes. And we also have a strategy to reduce our carbon footprint by 2030 and 2050. We recover some of the materials and investments made in our plants, like containers and cylinders, and we also reuse water and white waste from our process. Steel comes back to steel. That is our motto. We have a circular process. So in steel making, as we can see on screen, we see an electric steel maker that does not just use power, but mainly power. In our process, we also manufacture other products in a productive area, that is the layering area. So these products are different reinforcement bars for the construction industry, but we also manufacture profiles and other bars, where profile is for the metal industry, from which we also recover their scraps. And we also have clients in mining, fortifying nuts and bolts for tunnels in the mining industry. So the process, as you can see, is quite circular, and the scraps that we collect across the country is reused. Now, I wanted to describe what we do. So first of all, we are committed. We build a roadmap by 2030, 2050 to assess whether we have the possibility to reduce our footprint. We conducted an assessment with SBT initiative, and they validated our roadmap. And looking at different alternatives, we were able to reduce almost 1 decade before our goal was by 2030, but we reached this goal in reducing the footprint 10 years before. We want to be net zero by 2050. Of course, that is a longer term, and our objective is reducing emissions by 50% by 2030, level 1 and level 2. We are based in 3 main pillars: renewables, electromobility, and energy efficiency, as my colleague said before. And we've also set a 4th pillar for green hydrogen. Hydrogen is an alternative. The figures are still not great for a full transformation, particularly this phasing out fossil fuels, but we are looking at different pilot projects for this replacement. And very quickly, some actions that we have adopted in the different levels. For level scope 1, these are the main input and raw materials for our company, natural gas included. We conducted a study for our roadmap for scope 1 and 2 in a steel-making industry producing steel in Germany, and the main milestones are reducing carbon, powers, replace. We've done pilot tests replacing carbon use for steel making by rubber, and by capturing and storing CO2. We improved our energy emission processes, and we have looked at the heat recovery so we can reuse it. In one of the operations We are at the laminator or the plate mill. We're working on a blending on a 50% hydrogen to replace natural gas. Direct, indirect emissions or electricity, that is scope 2. 80% of our company is electric, 70% is natural gas. We've certified our consumption with renewables. Uruguay, Chile, and other countries in the region lead in terms of renewables. And that makes it possible for us to obtain that energy and reduce that scope. We have different initiatives with Chilean agencies. For the Energy Efficiency Award, we implemented ISO 50001, and that really encouraged the entire company to look for continuous improvement in energy processes. We have investment projects to again clean up scrap, which is our main input and raw material, $25 million, but that will contribute our profitability and in the reduction of power use. In that same line, we have solar projects in the pipeline for self-consumption. These are smaller projects, but as we come closer to 2030, we are analyzing the possibility of generating this in our own plant for self-consumption so we can continue reducing our use of power. Scope number 3, we are mainly working on electromobility, scrap, and the product is transported in diesel trucks. We are looking at a gas transition and electricity as well. All of this leads to one of the lowest footprints, as Gaston said, especially in our company. It's 0.17 tons of CO2 per ton of steel. The average of a semi-integrated industry is 0.67. In 2020, we had 0.5. Today, we have 0.17. And the average globally is 1.91. So we're quite happy with these results. We've achieved some of the goals before the deadline. But of course, we're going to continue making further progress. We are not just going to rest in our laurels. The second part of your question, to answer the second part of your question, circularity is part of the DNA of the companies. So the waste in the different processes. We had it. So what did we do? We started researching. We set a goal by 2025 to fully. We purchased a subsidiary company, Fiasa, where we took the waste from our furnace or kiln, and we are using it. Now, we went through a regulatory process in Chile because in some places this waste can be used, but in order to be used as a co-product and to have economic value in terms of the environmental aspects or financial aspects, the transition has to come with competitive prices. The steel industry is an industry that cares about costs. The higher the production, the lower the cost, the more investment or progress we can make. So I think that is all on my end for now. Thank you, Rodrigo. This has allowed us to have, not only a more global perspective, but look at a specific case of a company with a long-standing tradition and a company that knows very clearly how they want to do business in an industry that is so particular, like steel making. Let's now move on to a different sector and see what's happening in the cement industry that also has a very important role in the heavyweight industry. So, Ricardo, can you tell us about some of your milestones and achievements in the cement industry? Again, when we speak about emission reduction, when looking at the milestones and what we have achieved, what are the next challenges, what we're doing, where the cement industry is going, etc. Thank you, Gaston. Thank you, Olade, for the invitation. I am very happy to be part of this very good panel. And thank you, Patricia, for your presentation, because really you mentioned some of the figures that I was going to mention as well. But I will present some of the technical aspects of the industry. For example, this global picture does not represent the regional picture. Sometimes this is far from the statistics. The global south many times is not present in statistics, and these are led by the developed economies. Now, when it comes to the use of construction materials, such relevant materials like cement, sometimes leaves us far from finding a solution. 7 to 8% globally, but when we look at Latin America, same as steel, we go back to a 3%, and the use of soil is still one of the biggest emitters in the region. So just by looking at technological sectors, as the global north proposes, might not be as valuable for us here in this global south, particularly when we speak about a sector that has that goes hand in hand with the development of and the with poverty. We look at a sector that's not been developed, that we don't have drinking water, that 20% of the roads are paved, that 80% of housing and households are vulnerable, and 80% in Central America don't even have cement floors, but rather soil, and that causes children to get sick. And studies of Habitat for Humanity shows that since they miss school, they have cognitive development issues as well, and poverty is reinforced. So when we look at the different realities, we know that the local context and regional context is very important. Gaston asked about milestones. In 2001, the cement industry issued a protocol for scope 1, 2, and 3, and tier 3 emissions. We knew that this was a very relevant stakeholder, so the statistics are necessary. That methodology after 2006, when the IPCC issued their technology for the sector, was calibrated, and they published the 2011 model. 80% of all plants report under this methodology. The same is in Europe, North America, and pretty much everywhere using this methodology. And Latin America is the second region with the highest number of statistics, which is rare. In our region, we usually don't have good figures or statistics. In 98, I was responsible for assessing our footprint. So we've been working on this for a long time, and today we have a more comprehensive understanding of the decarbonization route. In 2015, as you can see on screen, the COP, we need to parameterize, and in 2015 we decided a roadmap for Latin America to decarbonize the cement industry. But at the time we didn't have statistics from public policies, government, or even the plants themselves. We did not have statistics because they were consolidated for the region. So something that at the time was a barrier is our main asset today. We develop roadmaps in the different countries. I have led 12 from Mexico to Argentina, Chile, and Central America and Caribbean. So having worked in different plants, different countries, different regions, allows us to today have a very comprehensive understanding of how to decarbonize a plant, a country, and the challenges and contributions of our industry. So at the time, this was a weakness for us, not for Europe. Europe had the European Parliament as the negotiation and association, which is not the case in China. But in Latin America, we had to build it from scratch. In 2021, promoted by the IPCC, that it established that we need to go below 1.5. We have a carbon neutral commitment, and we are working on reconverting and modifying our existing roadmaps, looking at 2050 and contemplating the entire life cycle. It would be a big mistake to forget to mention what the other regions are doing. China accounts for 56% of cement production. They have their own roadmap, and they have considered the deployment of hydrogen as fuel and what this will entail, the costs associated, and etc. So this is one of the key roadmaps, the use of technology, and when will it be developed. Now, if we speak about local and regional differences, China will reduce their cement production and consumption by 31%. by 2050, 31%. So if a cement mill or cement industry, I ask them to reduce the 30% their emissions, it is the market that will reduce their emissions. If I do the same in Africa, Africa needs to increase by 300% their use or consumption of cement. So it is very different to decarbonize in a production or in a market that is reducing or slowing down to another. And the impact of the wrong decarbonization is on the price, the unit price of housing, of road building. So the impact will be assumed by countries. It's not a transference that is easy to do when looking at the decarbonization without considering the impact. Words that didn't exist before, inflation, for example. If Europe wanted to transfer the cost of carbon reduction to consumption, their inflation would increase 4 or 5%. I don't think no government can survive that, considering the current rates. So we need to model these solutions looking at the reality in the countries. Governments have understood this message because they are critical stakeholders, and they started negotiating with the cement industry in China, in the US. In the US, for example, they have a high consumption. They use the cement with the highest clinker component, and that is the highest CO2 emitter. So we need to replace clinker with other additions like slag, like ashes, and others. So all volcanoes in the Andean range are limestone that was calcinated in natural form, and that raw material has no CO2. Therefore, it is useful for cement production. What the US doing is what Chile and Brazil have done back in the 70s. So their roadmap is a roadmap of something that has been done before, either in early industrial action or even naturally. In Europe, a model that is associated to the legislation of the Green Deal of the European Parliament and carbon neutral, and the transference of that cost will be vested in the market. So how does the market model with this general legislation what China does with the slowdown? But we need to consider Africa. Africa is growing at 300%. India today have 1.2 billion by 2050. It's almost the population of Latin America. Industry accounts for the entire Latin America cement industry, plus they need to cover a deficit for the lack of housing and infrastructure. So we also need to consider the vision of the global south to see how we will decarbonize the industry. Our models show that all the cement tons will remain stable. We had a 30 to 20% consumption, but to have a more efficient decarbonization route in the use of cement, that will cause a reduction of 30%. So what we emit now is what we need to decarbonize by 2050, because the efficiency of our product will be the same growth projected. So the first work we've done in negotiating with global associations like the PCA in the US, Tiburon in Europe, now we want to negotiate with India as well to understand what the roadmaps will be like and provide certain sustainability to our strategy. That figure is quite important. A person that's living in an emerging country, they have 10 tons of cement. If you live in a developed country, you'll have 30 tons of cement. So can we leave our continent without access to drinking water, clean energy, and roads? And the story becomes more interesting. Vulnerability in Guatemala to climate change is the roads, for example, and roads being cut because they live from survival agriculture. So if roads are cut, means that they will not generate income, and we go from poverty to extreme poverty. So road infrastructure is a need for the survival and not to fall in extreme poverty. In the north of Peru, they have extreme rainfall, roads are cut, and the country is disconnected. One of the research of MIT shows that concrete roads versus asphalt will save 4 to 6% of the fuel of the low cargo that uses those roads. We speak about electromobility, but what roads are they going to use? What is the efficiency? The MIT has also looked at this because they're focusing how we understand the product in the market. A concrete house, for example, in a hurricane-prone area is cheaper rather than wood because of insurance. Insurance is very expensive in the U.S. So we need to look at the economic model. So it's not just about footprint of construction, but we need to look at the life cycle as well. I'm in Uruguay. What can I speak about in Uruguay? Well, the Centenario football stadium is turning 100 years. So it will turn 100 years for the different soccer games, and it will be standing for another couple years or decades. But the Centenario Stadium is now a great cement construction. It was built almost 100 years ago, and the new World Cup stadium will be built using the same structure, and even, and this is a lesser known fact, is that concrete fixes CO2. For example, in clinker production, it fixes 20% of the total footprint, even more depending on the application. Estadio Centenario has fixed 20% of the footprint that it emitted when it was built. The same with the Panama Channel. The footprint was neutralized in 1 year. But since the use of cement is so obvious, we disregard it, and the story that's been told about us is quite unfavorable. So we need to look at the quality of life that this material offers, and we shouldn't increase the amount of the price for the product that will continue to push people to poverty. So this is something, well, here we can see the 12 roadmaps that we have developed across Latin America. The Mexican was the latest. The Ecuador is soon to come. Chile and Colombia were the first countries developing the carbon neutral roadmap in economy and development. The other ones only focus on economy. So for the first time, we are looking at the keys of how to understand decarbonization. These were done plan by plan, operation by operation, using different data, type of fuel, raw materials, kiln. They're quite efficient. The plants are quite efficient in Latin America, and this is normal. A young continent, and development is quite young in Latin America, even more so in Africa. So the plants are new. Plants are going to move towards cement use is increasing, not when it's done. So the plants in Latin America are quite efficient. 20% of the thermal energy, which is the highest demand of our kilns, comes from waste in Latin America. Many countries, for example, tires that are no longer used, or urban waste, we are looking together with the IDB how Trinidad and Tobago that have a serious waste management problem, if they can be used by cement mills, replacing fuels, capture CO2, and therefore contribute them to other green products. We consider the energy transition. When I had to promote this technology in Chile in 98, when I started working with a cement mill, they said, no, we need to use natural gas. Waste is a third world thing. The world's changed quite significantly, and sometimes we forget that story. Today, Austria, 90% of the energy comes from waste, and that's an interesting story. When the war between the Ukraine and Russia started, power consumption in particular had problems because they depended on natural gas only, which was not the case for cement mills. Now, this is our roadmap for the decarbonization in Latin America. We are looking at 15 pillars in a technology efficiency scenario, 3D, pre-manufactured, or more specialized AI in the use of cement. We can save 35 of the cement that we were going to consume by 2050, and that is the baseline. If we go from regular cement concrete to industrialized. And then we'll see how to decarbonize, and we have biomass, alternative fuels, hydrogen, but there is no single solution. There is no, okay, we'll change waste per carbon and that's it, or carbon neutral. Power or electricity will triple the consumption in plants. So this will increase demand threefold. So by 2050, the footprint using these models is about 8%. We need to capture the 3 times the energy low in carbon. So all of these international conversations lead us to think that Latin America has many opportunities in the cement industry. Europe and the US say that they will decarbonize just by using technology. We have said that we will contribute with different solutions, for example, methane in landfills that are avoided, the waste that we are co-processing, which is not the case in Europe. In Europe, they are not going to have landfills by 2050. We have 1/3 of the waste in Latin America is not collected. 4% is recycled. So landfills will be part of the solutions for responsible waste management. Methane will be more significant if we can prevent that waste from getting. We have many plants, cement plants in Latin America, so we will have a significant reduction. We want to use the methane hub. And then nature-based solutions. Our forests have a good deforestation rate, and we've done the modeling. If we are focusing on that 9% out of all of that CO2, doesn't account for more than 3 months of deforestation, and this happens in Latin America all the time. And if we reduce the entire footprint and we went for no technology transformation, is the deforestation that we have in Latin America by 1 year. It's a viable solution. I mean, we would rather not go for that one after energy, fuel, more efficient products, and if by then we don't achieve the goal and we cannot transfer this to the market, because again, and this is a big difference for steel, what is the price of a ton of steel? $1,000, $2,000. Well, for cement is 100. So 100, a ton of cement is a ton of CO2. We cannot do the sequestration in the air or transference because the price of the product would increase 3 or 4 times. And it's hard to transfer these to the market. It's harder for the market, harder for the end users, which are all our countries. So this is a vision for the entire life cycle, all the models we are generating, we are calculating all that data, and that is part of the instruments that we have used with the IDB for a more responsible assessment. And that shows that electricity, which is one item in our, goes from 23 terawatt to 65, 69 terawatt due to hydrogen and capture. We need the support of the energy sectors as consumers ourselves to be able to go through with that transformation. Thank you. Great.
Al menos desglosada por sector dentro de la industria pesada.
That has allowed us to look at a different perspective from the different sectors. And we have, well, maybe more questions for the different panelists. One, how do we fund all of this? This is what the steel making industry has done. This is what the cement industry has done. Out of everything, for example, you spoke about reductions. Which of these could we use for other industries, for other sectors? What do your two industries share? And now it is up to the different organizations bringing together these sectors, what they can do to replicate the model. So Patricia, Ricardo, Rodrigo, what do you think about funding and scalability or replicability in other sectors? Patricia, did you want to start? Thank you, Gaston. We can identify many synergies in the sectors. And the IDB is really promoting this road. We need to look at the barriers like public policies, regulatory frameworks, and funding. Funding is another obstacle. We want to accelerate this process. So we need to look at different possibilities to find clusters, like Christian mentioned. and to share risks, investments, and optimize the process.
Buenísimo, buenísimo. No sé, Ricardo o Rodrigo, si quieren aportar algo más.
Sí, yo
Ricardo?
volver a insistir en que esto tiene que estar en el ADN de la empresa para ir a buscar
Yes, this has to be part of the company's DNA to look at different investment possibilities and prices,
desde llevarnos más allá del proceso actual, innovar en
to
términos
innovate in terms of technology.
buscando incluso electrificar una parte de la compañía donde consumimos combustible que es gas natural
We need
y de
we
alguna
are
manera
working on a part of the company that uses natural gas. And since Chile is trying to stay away from fossil fuels, we are also going to
la volatilidad de estos combustibles.
control volatility of these fuels.
La historia que yo llevo en la compañía hemos tenido
Since I've been at the company, fossil fuels have always had volatility, and that increases our costs. So if we don't look at a competitive industry where we can use technology that will not only help our processes, but also focus on circular economies that supports and helps our communities, environment, and society at large, we are not going to be able to
todos estos compromisos
fulfill our commitments to continue surviving in the steel industry.
Mira, yo trataría de resumir en 3 puntos
I would
la
summarize
industria y
3 points that our both industries share.
ese ciclo de vida.
One, we should do a life cycle analysis.
Entender su durabilidad
We need to understand recyclability, durability as the structure, not the materials.
yo creo que todavía la medición está en la puerta de la construcción y no en su
So we need to look at a construction, rather utility. I'm in Santa Cruz, Bolivia, 39 degrees, and they know that the asphalt roads melt with such high temperatures, and those 10 degrees heat will cause different consequences, more conditioning use, and so it's not just about low footprint, but how that footprint will be distributed in the long term. Europe is already building a building with 2 lives. For example, you can build first a hospital that can then be used for a university. If I move some panels, some walls, that is fine. I'm not recycling something that is at the end of the life cycle, but I will design it from the beginning. I think this is a just competition for the materiality to mitigate GHG emissions in constructions. Is not about the materials, the contribution, but rather the use of the buildings. And another very clear example for the electricity sector that Spain has modeled is the concrete construction, as they have a thermal construction. When, for example, when the sun comes down, the building will cool down later because of the thermal access, means that electric power consumption is different and your peak demand will be lower. That is a model that has not yet been adopted in Latin America, but it makes a lot of sense in very hot or very cold countries. Christian also asked, why are we not investing? We need more legal certainties. We cannot invest in hydrogen or invest in sequestration unless we know what will happen to legislations in 5-10 years. Is our material going to be benefited from decarbonizing in the future or not? So I'm here. I have participated in other events with the IDB to really convey that message. We need legal and policy certainty and stability. And the third one is the financial support. Hydrogen, cement industry, sequestration, all of these actions are doing in order to, considering state and large investment. In the global south, we don't have that. Our governments don't have those capacity. And something that was signed in Paris, well, for example, we are measuring gas matter, we have PDAs, but what has not happened is we are not receiving those $1 billion in funding from the developed to the developing countries, and in developed countries, they are responsible for their CO2 emissions, but they've grown, they have the infrastructure in place. So that financial transfers, Article number 6, is one of the needs, more urgent needs that we have. And I think these 3 points are very replicable in other sectors or other CO2 intensive sectors. So CO2 incentive, and we are also vulnerable to international trade.
Somos bastante pesados nosotros.
And funding. Okay, so what can we do since Rodrigo is here? If ASA wanted to develop high green hydrogen aspects and use it for their kilns, for example, Corfo is the local development bank. It's a facility of $400 million of the IDB, funding of the European Investment Bank, KfW Germany, 1.2 billion in total. So we can develop projects when it comes to kilns, for example, to inject green hydrogen. We don't have the global H2 in Europe or the facilities in the US, but we have the climate funds. So we can get concessional funding, climate funds, get rates, and work it with a second tier bank like Corfo in Argentina. We can do it in Brazil, we can do it in Colombia, in Mexico. All of them have second tier banks that can take on these funds. And there are two forms. Either the bank will take on funding, so then we can contribute it to a project, because that's how the program was developed. Or we can, for example, fund an SME with a development of an innovative injector, kiln, or furnace. So we can receive funds from a second tier fund and maybe a matching fund from Ceromita, Cemex, or any other large company. Many people might question, why should the IDB fund or subsidize large companies? But that's not the idea. The idea is to accelerate the decarbonization process, and we need this different types of support. So that is just to show what we are doing in terms of funding. We just signed 2 days ago, Certilac, the main industry for certification in the region. 14 countries signed it, and now in COP, together with El Acero, together with FISEM, together with ILADE, and the new Association of Hydrogen Associations for Latin America, we can sign a decarbonization declaration for the sector. So we have production, we have off-takers, and we need to accelerate the decarbonization process. So we are going to develop a publication where we look for the best practices in the sector. You called it? Well, I don't want to call it heavyweight industry, but what did you call it? You are a marketing expert. An CO2 intensive sector, and we want to reduce the carbon footprint significantly. Okay, do we have 10 seconds? Is there a question? Is this study published? It's under peer review right now. It's gone through the main peer reviewers, We will publish during the COP, that is first week in December, and that's when it will be available. There will be 2 publications: the full certification guideline, so the countries know the mechanisms that they need to adopt to certify in green hydrogen, and this guideline that reviews cement, steel, aluminum, pulp, and paper. The roadmap of the cement industry, is that roadmap publicly accessible? We have produced 12 roadmaps for the countries, and 8 of them have been publicly published. Some of them, Chile and Colombia, are published. Some countries have chosen to keep them private. So one of the really acknowledgement is that the roadmaps are really very thorough and detailed. I have 2 questions. What about the decarbonization of the limestone industry, which goes hand in hand with construction and cement and so on? We are usually contacted by companies that want to replace many cubic meters using more efficient furnaces. I can't hear him very well without the mic. Christian, you spoke about fertilizers and carbon sequestration. Green hydrogen could be helpful for that green hydrogen product. Thank you for your question. I think I can start and then you can continue, maybe Patricia. Something that we failed to mention before, and it's important, is when Ricardo spoke about the co-production of solid waste in the cement industry, 90% solid waste, 10% cement. But for the chimneys to continue emitting CO2, but the chimney will continue to emit CO2. So that's where we can combine CO2 with hydrogen to produce methanol. That's why when we mention clusters, the lime cluster or other industries like fertilizers, we should look for infrastructure that we can share. So if we will need more energy, well, the type of industry will have to invest in cleaner energies, in electrolyzers. So it doesn't really make much sense that each company will invest in electrolyzers. Maybe a cluster of companies can do it instead of doing it just one company alone. Taking those emissions, because we have quite a pure CO2, and that CO2 can be combined with hydrogen to produce ethanol, and then producing or using shared infrastructure for that methanol to go to a port and be sold as a byproduct of these industries or burnt in those same furnaces. So we can work on circularity. So you produce clinker, lime, it's practically the same. So we can use slag from the metal industry, but lime is lime. One of the main problems with lime is that it doesn't have a union like the union that Patricia leads, or mining cement that streamlines criteria. It's not a strong union, so we've worked with other industries supporting them from our cement industry, but the footprint will depend on the products. The quality of lime will determine the intensity of the footprint due to the chemical processes. Low CO2 fuels, but the ways many governments in the region are recognizing themselves as carbon neutral, even though there is emission, but the methane or CO2 that you have in the waste sector, it recognizes carbon neutrality. So after energy efficiency, we need to look at alternative fuels. As Christian said, these fuels are going to sacrifice the lime and clinker, so hydrogen is a good heat corrector and not be used as fuel itself. I think that's how the hydrogen will be used in the lime and cement industry. There's lime of such quality that you can transfer the cost of that sequestration to the product. If that were not possible, you should look at our solutions. Since you don't have a very well structured union, you can maybe use ours as a model, and the technologies that have been used, and cement industries have bought lime companies, so basically they are part of the same holdings. Last one. I can't hear him without the microphone. So we just visited Spain. In Spain, they usually have quick public policies that are effectively implemented. So the Bermuda Triangle of all of these things is industrial scalability. Many things work in the lab, but when you have a very large industry and you're going to build a building that needs to be sturdy, or a bridge that needs to be sturdy, scalability costs. In terms of recycling, well, we need to consider the cost of the materials and the circularity of the product. And there is a very important attribute. I told you Maracana is carbonated. No, Centenario, I'm sorry, the Centenario Stadium. Well, the Maracana in Brazil as well. But what gets recarbonated is the surface layer. CO2 doesn't penetrate. If I were to take everything and work on it for 1 year, I would do it. That is called optimized or accelerated recarbonization. So we have a CO2, a potential CO2 fixing. Now CO2 is acid, and it can attack the ferrous structure in concrete. So we need to consider how we will use those raw materials after that. We can use it as arets. We are not going to avoid the cement, but rather the arets. That's another story. Now, if I look at the fine dust of that recycling, it's a higher demand of water that makes the cement mix more complex. So they would go back to the plant to become a raw material. It's a very ambitious cycle, but the same as waste. While landfill cost $5 in America and not much more like in Europe, they will have that destination. If areas are managed with very little regulation, well, that won't change. And again, regulatory frameworks is the key. In general, they are not very complex because areas are mainly used in public procurement, in infrastructure purchases. So if we focus on public works, well, the change could be quicker because the private actors will do it and the rest will follow. But yes, we really are studying it. up to 25%. We could use recycled areas for concrete without compromising the blend and maintaining the same quality that we have. The Netherlands is leading in this regard because they have no arid and they had to do it at the time because they needed to. And in Latin America, we need to consider the regulatory frameworks for waste disposal sites. Right, regulatory framework, I would say political will as well for all of that, and funding. Okay, I want to thank you all. I don't know if you want to say anything else just to close. Just to finish, I have a controversial statement. A very controversial statement. We have the road, we know how to get there, we have alliances and support. But something that is a big concern in Latin America is the competitiveness of the industry. Steels coming from Asia, from China, with prices that are not competitive, that don't compete with our national production. So together with some, for example, border policies in Europe, it means that all of those products will come to Latin America rather than Europe. Now here, we don't have incentives, we don't have regulatory frameworks, so we need to invest in other things, as Ricardo said, and really we are impacting our industry. We need the support of governments to instill barriers, to provide the infrastructure that we need to advance in a decarbonization process. Thank you all. Have a great rest of your day.